All right, today we're looking at 8.4, multiplying special cases. And so in this first key concept box, we're going to look at the square of a binomial. And on the left-hand side, you can see kind of the general algebra rules. And on the right-hand side, you can see an example. But the definition is the square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last terms. I'm going to show you the shortcut. But know that you can also just split this up into two binomials and then multiply them like you've done in the previous section. Okay. So let's look at our examples. And I'm going to actually start with what I've written in green. Okay. X plus 4 squared. You notice that the square is on the outside. Now, some people are going to think, don't I take that square and multiply it times all of the exponents on the inside, because our rule is the only time you multiply exponents is if the exponent is outside of the parentheses. But remember, that was only the case when inside the parentheses was all multiplication. There wasn't any addition or subtraction signs. Okay, so the quantity of x plus 4 squared actually just means we're multiplying x plus 4 two times. Okay, so you can look and see that I've split up x plus 4 squared into two binomials here. And so we can multiply those like we did in the previous unit. You can take the x and multiply it through, and you get x squared and then 4x. And then you can take the 4 and multiply it through, you get 4x and 16. And you can put your middle terms together, you get 8x. So you have x squared plus 8x plus 16. Okay, so you can split these binomial squareds into two binomials and just multiply. Okay, now left-hand side, it's the exact same problem. Here's the shortcut where you can skip the one step. All right, anytime you have a binomial squared, the first thing you do is you write down whatever the first term is times itself. So x times x is x squared. That's right here. Okay. The next thing you do is you're going to multiply the two terms on the inside together. Okay, so we have an x and a positive 4. So when you multiply them together, you get 4x, and then you just double it. So when we get that and we get 4x, and then we multiply that times 2 every single time, that's how we get 8x. Then we're going to take our last term and multiply it times itself to get our last term. So 4 times 4 is 16. And that gives you just a little shortcut that cuts out one step. Now, you don't have to do that. That's just a shortcut for you in using these special square rules. But you can always split them up into two binomials and multiply them like you've done previously if that's more comfortable for you. Okay. Then we have this rule called the sum and difference rule. I like the sum and difference rule because it's pretty easy math. All right. If we look at the rule at the top, you've got a plus b times a minus b. So the product of the sum and difference of the two terms, okay? So this is called difference of squares. And it's called difference because remember, difference means subtraction. So we have the same two terms, a and b, but we have a plus sign in the middle of one and we have a minus sign in the middle of the other. What that does is, if you look at the red in the middle at the top, is our middle terms are always going to cancel out because one's going to be positive and one's going to be negative. So the nice easy rule for the difference of squares is you take the first term squared or times itself minus the second term times itself, because the middle terms always cancel out. So let's take a look down at the bottom in the green again. We'll start with green. You got x plus 8 times x minus 8. Okay, and in my head, I see it's difference of squares. I can already see it. But if I show all my work, x times x is x squared, x times negative 8 is negative 8x. Then I distribute the 8 through. 8 times x is 8x. 8 times negative 8 is negative 64. Well, what do you notice about the middle terms? You got negative 8x and positive 8x. They're going to cancel each other out. So you're left with x squared minus 64. So if you can recognize that you've got difference of squares, all you have to do is multiply the first times the first and the last times the last, and that's your answer. Okay? Now that only works with difference of squares. If they both have the same sign, then we're back up here to the top doing the square of a binomial. Okay? All right. We're going to simplify each expression. Okay? So I'm going to do it the shortcut way first, and then I'll show you the way that we've done it in the past. All right? The shortcut way is for me to take 2s times 2s, which is 4s squared. Then I multiply the two terms together and I get 8s. 4 times 2s is 8s, and I double it, which gives me 16s. And then I take the last term and I multiply it times itself. And that is my answer. Okay, now to show it using a distribution, 2s plus 4 squared just means I have two of these. Okay, 2s times 2s is 4s squared. 2s times 4 is 8s. 4 times 2s is 8s. And 4 times 4 is 16. Put our like terms together, and you can see that we get the same thing. Okay? One more time. Shortcut method using the special rule. 6m times 6m is 36m squared. I multiply my two terms together. 6m times negative 2 is negative 12m, and I double it. So negative 12m doubled is negative 24m. And then I take the last term times itself. So negative 2 times negative 2 is a positive 4. Okay. And now we'll do it using distribution again, just so you can see that they are the same. 6m times 6m is 36m squared. 6m times negative 2 is negative 12m. Negative 2 times 6m is negative 12m. And negative 2 times negative 2 is a positive 4. Put our like terms together. And we get the same thing. Okay, again, you can use either of the methods. Okay, the figures below are squares. Find an expression for the area of each shaded region and write your answer in standard form. Okay, so to solve this problem, area of a square is side squared, right? So I'm going to write it up here. Area for a square is side squared, because the sides are the same. You can do base times height or length times width. It doesn't matter. It's going to end up being the same thing because it's a square. Okay, so it looks like this. But I also have to subtract the little square. Okay, now you can use the distributive rule if you want to, but for the purposes of this unit, I'm going to go ahead and do the shortcut method. Okay, and write these out. So I'm going to start with the x plus 2 squared. So it's the first times the first, which is x squared. Then I multiply them together. 2 times x is 2x, and I double it. And 2 times 2 is 4. Now, I have to make sure I put a parentheses here because I'm going to be subtracting all this. So I'm going to run the negative through eventually. I'll do the same thing. X times x is x squared. Multiply the two together. So x times negative 1 is negative x. And then I double it. So it's negative 2x. And negative 1 times negative 1 is a positive 1. Okay? So what I need to do now is I need to run it through. Now, I remember some of you liked to see it stacked, so I'm going to go ahead and do that too. Here's x squared plus 4x plus 4. I'm going to run the negative through, so that becomes negative x squared, positive 2x, negative 1, and now I can just add them together since I ran the negative through. X squared minus x squared, that goes away. 4x plus 2x is 6x. 4 minus 1 is 3. And this is the area. Technically, I should be writing units squared, I guess. Since it's, okay. Now, I'll do it the other method, just so you can see it. I'm going to take, for this one, x plus 6 times x plus 6, and then I'm going to subtract x times x. Okay, so I'll distribute it through here. That's x squared plus 6x plus 6x plus 36 minus x squared. Okay, I'll put my like terms together. Okay, x squared minus x squared, that goes away, and I'm left with 12x plus 36 units squared. Okay, so area of the big box minus the area of the open box. And those are all in standard form. Okay, mental math. I think that we've kind of shied away from mental math, and I think that's an unfortunate thing. I'm going to show you my process on this mental math and how it fits with this section so that you guys can understand why it's here, okay? If we wanted to figure out 48 squared, there's not too many people that can figure out 48 times 48 in their head, okay, without a calculator, all right? I'm gonna, even though it's mental math, I'm gonna show you the process of doing this mental math the easy way, but I'm gonna write out the steps that I would be doing in my head just so that you can see it, okay? So if I were trying to figure out what 48 squared was in my head, I could do an estimate easy. I could say it's 50 squared and that's close, right? But if I needed the exact answer, I would just use the rules that we just learned. I can do this math in my head, okay? Isn't 50 minus 2 squared the same as 48 squared? Okay, so in my head, what I would be doing is I would be solving it this way. 50 squared is 2,500, right? I take the first term and I square it. Then I multiply the two together. Well, 50 times negative 2 is easy. It's negative 100. And then remember, you have to double it. So that would be negative 200. And then it's the last number times itself. So negative 2 times negative 2 is a positive 4. So in my head, I could have done this math. 2,500 minus 200 is 2,300, and 2,300 plus 4 is 2,304. Okay? So that would be using mental math to solve it, and you wouldn't need a calculator because you made the problem easier for you. So for 89 squared, we would do 90 minus 1, right? So here's what it would look like in your head. You would be solving for 90 minus 1 squared, right? 90 squared is just 9 squared with 2 zeros, so 8,100. 90 times negative 1 is negative 90. We have to double that, right? So that's negative 180. And then negative 1 times negative 1 is a positive 1, okay? So this is what we would be doing kind of in our head to figure out what the answer is, right? So you can process this through mentally. I think most people would think that the blue one is probably easier than, I mean, I think this, oops, my pen ran out. I guess I should finish the problem, huh? So 8,000 minus 80. Whoa, my pen's messing. Won't keep writing. There we go. okay? And then you still have the plus 1. Right, now I think that this green one would have been a little bit tougher for people personally, but I mean, you can see the process, and without a calculator, you could figure this out, writing it out using this method. Okay. All right, that's mental math. Now, down below here, we're going to be, as soon as my screen stops bouncing around, all right, we're going to be looking at this, and what we want to notice is that this is difference of squares. Now, I still think I want to show this to you written out so you can see it, but then I'm going to show you how the simple rule takes effect, because the middle terms will always cancel out in difference of squares. So let me use the distributive property first, just so you can see it. V times V would be V squared. V times -7 is -7V. 7 times V is 7V. 7 times -7 is -49. And you can see that these middle terms right here are going to cancel out. So you're left with V squared minus 49. So if you recognize that the binomials make a difference of squares, which means same terms, but one's got a plus sign, one's got a minus sign, all you have to do is multiply the first times the first and the last times the last. Okay, so for B, it's difference of squares, same terms, but different sign in the middle. 2c times 2c is 4c squared, and 3 times -3 is -9, and we're done. So you cut out a step. Okay? And that's the entire 8.4. That's multiplying special cases.